Once upon a time, there used to be a big galaxy of stars called the Milky Way. A family of 8 planets and a star used to live there. Sun was the name of the star, and he was the head of the family. He was an important person as he emitted light for all other planets to survive. The planets ran here and there to capture sunlight. They would bump into each other very often while trying to do so. This became a really big problem. All the planets called for a meeting and decided to find a solution. They agreed upon playing a game at the end. Their head explained to them the rules of the game once again. The game is called Spot the Lights. Each of you all will be assigned 8 round paths around the sun, away from each other. Your paths will be known as your orbits from now on. The planet who will collect the maximum light, who will be the winner of the game. All the planets loved the game and played it every day. They play it even today. So you already know that in our Milky Way, all the planets revolve around the sun in their respective orbits. Do you know where else this pattern can be seen? To find out, let's dive into today's chapter, Structure of the Atom. Firstly, we have divided this entire chapter into 4 small parts. In this video, we will focus our discussion on topic 1 only, where we will find out what cathode and anode rays are and how they were discovered. Alright, tell me what happens when a plastic comb is used to comb dry hair and is brought near small pieces of paper. The comb will attract those small bits of paper, right? What did this experiment tell us? This told us that rubbing of 2 objects made up of matter together produced some feeble electric charge which attracted the paper bits towards it. Further, as matter is made up of atoms, this suggests that there is a presence of charge in an atom. As you know, John Dalton put forward his atomic theory in 1803, where he proposed that an atom is the smallest, indivisible and indestructible particle of an element that takes place in a chemical reaction. But this concept of indivisibility of atom was disapproved by experimental evidences obtained towards the end of the 19th century. We will know about those experiments in detail throughout the video. So let us see how electrons were discovered. William Crookes in 1879 studied the conduction of electric current through gases at low pressures. For this purpose, he took a long glass tube of around 60 centimeters length, sealed at both ends. It was fitted with 2 metallic electrodes at the ends and also had a stopcock which could be connected to the vacuum pump to create a desired low pressure region. Such a tube is known as a discharge tube, and this is how it looks like in real life. When 10,000 volts are applied between the electrodes, in case 1, when air pressure is 1 atmosphere, no current flows between the electrodes because gases are poor conductors of electricity. In case 2, when air pressure is reduced to 10 to the power of minus 2 atmospheres, electric current starts flowing and a green fluorescent glow is observed behind the anode. Why green? It does not have to be green necessarily. It depends on the color of the gas used in the discharge tube. In the last case, we will see that when the pressure is further reduced to around 10 to the power of minus 4 atmospheres, glow between the electrodes will disappear, but current will keep on flowing. However, the entire tube now glows with a faint greenish light. All these help us reach a conclusion that some invisible rays are originating from the cathode, and thus those rays are known as cathode rays. J.J. Thomson repeated this experiment multiple times and found out that cathode rays have the following properties. Number 1. Cathode rays emerge from cathode and move towards the anode. Number 2. If an object is put in the path of cathode rays, the rays cast a shadow. It means that cathode rays travel in a straight line. Number 3. If a small paddle wheel is placed in the path, the wheel starts exhibiting mechanical motion. This means that cathode rays are made up of material particles. Number 4. Cathode rays carry a negative charge as they are deflected towards any external positive field. Number 5. And you of course have seen that cathode rays produce fluorescence and incandescence. On the basis of these very observations, J.J. Thomson postulated that cathode rays are nothing but a stream of negatively charged particles and named them as corpuscles of negative electricity. The name was later changed to electron and is represented by the symbol E or e raised to the -1. So, till now, we know that electrons are negatively charged particles. But what is the charge on them? Let's find that out. The charge present on an electron is -1.6 into 10 to the power of -19 coulombs. However, this is the smallest measurable quantity of charge and is therefore called 1 unit of electrical charge. In other words, the relative charge on an electron is -1. Thomson was a great scientist. While carrying out similar experiments on the setup, he was able to determine the charge to mass ratio of electrons to be equal to 1.7588 into 10 to the power of 11 coulombs per kilograms. Here, E is equal to magnitude of charge of electron in coulomb and ME is equal to mass of electron in kgs. Substituting the value of E as -1.6 into 10 to the power of -19 coulomb, we can easily find out the mass of an electron as 1.6 into 10 to the power -19 coulomb divided by 1.7588 into 10 to the power of 11 coulomb per kg. On calculation, we find out that the mass of an electron is 9.11 into 10 to the power of -31 kgs. As you just saw, an electron is negligibly small and has approximately 1 by 1840 times the mass of a hydrogen atom. So friends, that was all about the discovery, charge and mass of electrons. We will see you again in the next part of the chapter, where we will discuss all about anode rays and protons. Until then, goodbye and keep learning.